So thank you very much. And I'm also a partner of the Switch to Safe project. So I have a dual role. John set the framework very nicely in terms of energy savings potential through smart windows. Windows, as you all know, are indispensable part of a facade of a building, and the Commission recognizes the need for developing novel solutions that integrate the renewable energy sources, both for the opaque and the transparent components. So the Plural project, titled Plug and Use Innovation with Adaptable Lightweight Systems, targets exactly this, to develop innovative integrated facade components that combine passive and active systems, and that can be prefabricated and transported to the renovation site, minimizing costs in terms of materials, renovation time, and maximizing energy saving. So what we are trying to do in this project is to develop a palette of different offsite prefabricated kits. We call them plug and use kits because they take into account the building user requirements. And the key challenge is to understand how you can integrate these different components into one single kit and make them operate at the most efficient way in terms of energy saving and indoor comfort. What we want to do is to demonstrate that the integration of hybrid passive and active systems is feasible into one component, and to develop synergies for retrofitting buildings. Of course, as I said before, the target is, as John also explained, to be able to reach net zero energy building status after the renovation, which is a prerequisite for the European Union after 2030. To have cost-effective renovation, to have fast-track renovation, to be environmentally friendlier, and to be flexible and adaptable, because no building has the same requirements as the other. Every building is a separate entity by itself. We are developing basically three different types of PNU kits, plug and use kits. One is called Smart Wall, the Connex Wall, which combines a wood facade with external wall heating and cooling system, and the hybrid wall, which is based on a folding facade that integrates an advanced heat and cool recovery kit. I will show briefly to you in a minute how these kits look. In parallel, we are developing a digital platform which integrates the BIM models of the demonstration buildings with the specific technical characteristics of the PNU kits and key performance indicators that are developed as part of the project to prioritize the requirements and the needs of different decision makers. Decision makers can be architects, can be real estate, can be the user of the building. And the aim is to develop also a decision support tool that taking into account the BIM, the monitoring performance of the building, the BIM modules of the IFC files of the kits, and via this decision support tool to be able to support the decision making, which of these technologies best to be implemented in a building. Of course, in parallel, we have training tools, and one also specific issue of this project is the manufacturing. We have a whole work package which deals with how to optimize the manufacturing of these prefabricated kits, combining the BIM platform with the manufacturing, giving order from the BIM to the manufacturer what and when and how to manufacture, and of course applying the lean manufacturing principles in the factory quality procedures. So this is an overview of the methodology. We go from the definition of the key performance indicator to the development of the kits, testing, manufacturing, and validation in real demonstrators. This is an overview of the three kits, the smart wall, which you see on the top. It's a multi-component kit based on a metal frame that integrates a PV panel together with a fan coil and a smart window, which I will talk a little bit more in the next slides, plus a control system, which we call control toolbox. So the control system takes into account the indoor conditions, gives order to the heat pump that drives the fan coil to switch on or off, and also to the smart window, and of course takes the power from the integrated PV panels. This module can be produced in different forms, with, without window, with door, plain, and can be used indoor or outdoor. The one you see in the middle, the so-called hybrid wall, is based on a commercial technology of a Spanish company called Denvelopes. This is Denvelopes produces folding facades. What you see here in blue and light green, or the beige and red, are panels that are folding, and they are transported folded to the building site, and then they are unfolded and they go on a frame, and they create a facade to the building. Here the challenge is to integrate an air handling unit, which will take into account the indoor conditions and will improve the indoor comfort and will minimize the cooling load, plus to integrate the windows, because this is a lightweight facade and the windows can be quite heavy, and so there are some stability issues and sound issues, how to combine these things. The last one is called Connex Wall. It's based on a hydronic concept, namely similar to an underfloor heating system where you have the piping where the hot water circulates. The same concept, the same principle is implemented on a facade wall. You see a picture in the middle. And this is integrated with a prefabricated wooden wall, and it all comes together with the windows to be installed at the building. The architects among us can very clearly probably understand what are the challenges here. Fitting a prefabricated module like the ones we are developing to the actual building is really a challenge in terms of dimensions, hanging, transportation, a lot of small things that have to be taken into account. And I can tell you that BIM helps a lot in this direction, because you can have all the information you need. And for the renovation buildings, that we have, all the BIMs have been scanned with 3D laser scanning technologies. We created the point clouds, and then we created the beam out of this, and out of this beam, we gave instructions to the manufacturers on how to manufacture these prefabricated kits. Now, probably it's a little bit more interesting for us as part of the Switch to Safe project to see a little bit what we do in terms of smart windows. We have a partner who is developing a technology of a triple pane low E window, where they make the anti-reflective coating placed in different locations within the triple pane, and they circulate air, which is driven from the outside within the panes, and in this way they can save a significant amount of energy. You see on the top picture the inlet and the outlet of the ventilation which goes through the panes of the window. Apart from this, we integrate in all the windows heat recovery systems, and the ventilation systems. In the middle, you see a representation of the so-called toolboxes, which are necessary for all these kits. And these are the ones that combine the control of the panels plus the control of the building, and they try to make them collaborate. So, and the IT tools, I don't want to take too much time. So each of these P&U kits that we are developing has certain flexibilities and applicability to certain conditions. So as part of the project, we develop a database where we correlate the characteristics of each of these P&U kits to the building requirements. On the left, you see the 3 real buildings where these P&U kits are going to be installed. The first one is in Greece, where we have a Mediterranean climate with hot summers, and there we are going to install the smart wall. In the middle, you see the building in Spain, in Terrassa, which is a suburb of Barcelona, where we are going to install this folding facade, which integrates the air handling unit and the windows, because here the summers are a little bit cooler than in the south of Greece. And the one on the right is the building that is located in Kasava, in the Czech. And here we are going to install the prefabricated wooden facade with a hydronic system. Additionally, we have 3 more buildings, which are what we call virtual. Actually, we are going to do all the design work and all the energy assessment work, but we are not actually going to install. One is the one which is in alpine climate. It is a building in Bern where we are going to install the prefabricated wooden facade with a hydronic system that I explained before. The one in the middle is a building in Berlin, which is already renovated, and it has a very low energy consumption. You can see it's a wooden facade. This building, we are going to use it to compare the pre-renovation state with the traditional or conventional currently energy efficient renovation, and we are going to install also a variation of the smart wall to see how we can reach the NZEP status. And last but not least, we have a big demonstration site in Sweden, Väsby, which as far as I know, it's an area which is kind of protected. It's a typology of buildings built in the late 70s. And there we are going to install again the prefabricated wooden facade with the hydronic system because of the weather conditions. So as I said before, each of these P&U kits addresses different climatic conditions and different building typologies. Don't want to take up. This is a pictorial representation of what I said before in terms of installation of the 3 different P&U kits to the real and the replication demonstrators. A few representative examples of what we do in the frame of the project. We have a very extensive testing campaign where we look at the building physics and the thermal performance of these P&U kits via measurements and simulations. We also do in situ monitoring in different pilots in different countries, in Greece, in the Czech, and in Spain. We also look at the statics and the earthquake performance as well as the fire performance of these P&U kits in order to be compatible with the regulations of each country. Take into account that installing this kind of prefabrication of prefabricated kits in buildings and leaving them there, they should comply with all the local regulations, although they are not mass manufactured at the moment, at least. And as part of the project, we have developed an extensive list of key performance indicators that cover the energy performance, the thermal and visual comfort, time, cost, and environmental parameters. And this extended list of KPIs is a public deliverable of the project, can be downloaded from the project site, and can be used as a guideline for several projects to establish key parameters that need to be monitored in a building in terms of this classification: technical, environmental, economic, and social. For our project, these KPIs are going to be calculated on the IT platform that we have, and they will be used, the values that we will get, they will be used for prioritizing alternative scenarios based on the interest of different stakeholders. And last but not least, these are the target KPIs that were set by the Commission. You can see here that our main target is to demonstrate that the buildings after the renovation will be NZEB buildings, which means that the U value of the overall kit must be below 0.23 watts per meter square Kelvin. This already has been achieved in the design of the PNU kits. Depending on the country, the prime energy consumption must be definitely well below the 60 kilowatt hours per square meter. This is also confirmed. One of the targets is to be 58% cost efficient, i.e. reducing the costs for retrofitting by 58%, which is a huge challenge, taking into account the current doubling and tripling of material prices. Fast track renovation. Here also we have to prove that we can reduce the time for renovation by 50%. How we are intending to do this? Through the control of the manufacturing, and the BIM, combining the manufacturing with the BIM requirements and the sequence of the renovation, you can save up to 30% of the time needed, plus another 20% comes due to the fast installation on site. Actually, for the smart wall, which we have installed the prototype, it only took 10 minutes to install it, which is really a big challenge. The whole wall came and went on the existing wall, and it was really very nice. Environmental impact, of course. Most of the materials that are used to construct these PNU kits are recyclable, and it's a target to reach up to 70%. And adaptability, I think I already highlighted via this presentation that these PNU kits can be designed according to the requirements of the building. This was a very fast presentation, and maybe I created more questions than answered. And I will be happy to answer your questions when the time comes. Thank you very much.